Hello there. Okay, so in the last episode of this side quest, we designed and 3D printed this print-in-place fidget slider, which is based on this metal one that I got recently. I want to make a new version of the 3D printed fidget slider that incorporates magnets like the metal one. So let's do it. Real quick, before we get into the design process, I want to talk for just a second about how magnets work. Magnets are basically just pieces of metal that got little bits of gravity stuck in them when they were mined out of the ground. Or at least that's what I was told as a freshman in high school by the seniors on my robotics team. Wait a second. I think they lied to me. Anyway, if you want to know how they actually work, I put a link in the description to a video by Minute Physics and Veritasium that does a great job of explaining it. Watch that one after you finish this video. Back on track. So my goal in this episode is to design a 3D printable fidget slider that incorporates magnets in it. These magnets will index its sliding motion into discrete steps as it's extended and collapsed. My target is to make the motion as crisp and snappy as the metal fidget slider. Since this version will be printed as separate pieces, unlike the last version which was print in place, and will be only held together by the magnets, I want to incorporate a locking mechanism to keep the sections from sliding all the way apart when they're extended. If you want to try printing it out yourself, you can get the model for free on my things.com profile. The link to it's in the description. I've also included a link to the exact magnets that I used in this project. Lastly, I also have affiliate links in the description for the material that I used, as well as all the 3D printing hardware that I use, in case you want to try any of it out for yourself and help support the channel in the process. Now let's get to designing this in Fusion 360. Alright, so my main consideration when starting on this design was how I wanted to incorporate the magnets. I've seen a lot of models that will have you pause the print part of the way through, add the magnets, and then resume the print to close them completely in. I really considered taking this approach, but eventually decided against it for two main reasons. The first reason is that I hate pausing prints. I find that I have so many more problems when I pause a print part of the way through and then try to resume it. I've had layer shifts, problems with bed adhesion, and even just had the printer flat out refuse to resume the print. The second reason is that I wanted the magnets to be as close to the outside edge as possible. I'll explain why I wanted that towards the end of the video. For these reasons, I decided to go with the design with slots along the outer edge that the magnets just press fit into. I started by laying out all the main geometry in one single sketch. There's a strong argument to be made for limiting your sketches to just a single feature rather than putting a bunch of stuff into them all at once. That really probably is the best practice, but I find it much easier to visualize how the geometry will come together if I lay it all out in one core geometry sketch to begin with. One of the main advantages to sketching feature by feature is that you can then mirror or pattern the actual features rather than the sketches. Not only will this improve the overall performance of rolling forwards and backwards through the design history, but also it makes it much easier to adjust each individual feature in the future. Throughout this design process, I was repeatedly slapped around by the consequences of my decision to sketch everything in one big sketch at the beginning. Making adjustments to anything was difficult because Fusion kept locking up as it took its sweet old time to think through the changes that I had made. Putting too much in a single sketch is really a bad habit that I need to break, so learn from my mistakes and break things up more as you go along. With my base sketch done, I then used it to extrude the different sections of the model. I built off of these sections to form the main body of the slider, with the magnet slots along the edges. Once I was happy with how the base was looking, I moved on to modeling the lock, slot, and pin. The idea behind this is pretty simple, but figuring out exactly where everything should go ended up being really complicated. I wanted the slider layers to be able to extend so that there were always a minimum of 2 magnets overlapping. I got it pretty close to what I wanted and then just tested it manually by creating a copy of the slider and moving it to the position where it would be when it was extended. Along the way, I also did some refining of the magnet slots to make sure that the magnets would be able to snap in properly. Making the lock slot and pin was the main area that I had problems with my giant base sketch. Because virtually all of the geometry in the model was almost directly derived from that sketch, changing anything caused the entire model to have to be reprocessed. Eventually, I was able to get the lock slot and pin, as well as the side rails, modeled how I wanted them. So I exported the model and got ready to slice it for printing. I took a little more time than normal considering and planning out how I wanted to slice this model. The reason for this is that the tops of the magnet slots are all just bridges over the openings. I wanted to make sure that they would bridge over cleanly so that the magnets could still easily be fit into them. It turns out that all this careful planning didn't end up really mattering because the print failed from one of the sliders detaching from the bed. I was pretty sure that this happened because of the steep chamfers of the side rails and also because of a fairly sharp corner on the bottom surface. Even though the print failed, I was still able to test how the magnets would fit in the slots and immediately found that they wouldn't. I went back to the model and adjusted both the rail chamfers as well as the magnet slots, and then exported the model again and got it ready and sliced to print. This time it printed fine, but after printing a couple out and getting the magnets put in, I realized that this design just wasn't going to work. The rail chamfers just wouldn't nest together how I wanted them, and the top and bottom surfaces were just too thick, so the magnets had very little pull against each other. The magnet slots, however, did work well and let the magnets easily snap into place and even stay put with some pretty aggressive jostling. It was at this point that I decided that I was going to cut my losses and start a new version. I rolled all the way back to the base model and made some adjustments to the parameters. I then started working my way back forward through the model, redesigning each feature as I went. I first redesigned the lock slot and pin, and then I redesigned the rails. I made the rails much more substantial and also made them have straight vertical edges rather than the 45-degree chamfered edges. This added more bridging to the print, but I hoped that it would reduce the warping and therefore increase the overall bed adhesion. Since I was so concerned about the bed adhesion, I went a little bit overboard and printed the slider with a brim even between the bottom rails. This immediately showed itself to be a mistake, as it was impossible to effectively clean off the brim from the bottom edges. I also noticed that the bridging over the magnet slots was a little thin, so I went back to the model and made it just a little bit thicker. I also made some minor adjustments to the lock slot and pin, and then re-sliced it, this time with only a skirt around the print, no brim. This one printed beautifully. Absolutely perfectly. It stuck down to the bed with no warping at all. Once I got a couple printed out and got the magnets put in them, I tested how well they fit together and how strong the pull of the magnets was. They fit together like a glove, and the magnets were way stronger now since they were much closer together. The last order of business was to make a few final adjustments to the lock, slot, and pin as well as the rails, and then create the various versions of the slider. I made a flat top and a bottom version that have rails only on one side and the other side is completely smooth. I then made a plate version which is flat on both the top and the bottom. All of these versions, the flat faces are exactly the same distance apart, so you can stack them flat to flat no matter what version it is. Once again, I got a little over-optimistic with the print and sliced 6 of them together in one print. This print failed catastrophically when multiple of them warped and detached from the bed. The moral of the story is be patient. Only print one at a time, and when it's done printing, leave it on the bed to completely cool naturally. I scraped a couple off early before they were cooled down all the way, and it caused them to bend and warp. One other tip for putting the magnets in is get the magnet started about halfway in the slot and then firmly but carefully press the edge of the slider with the magnet onto a hard flat surface. I found this to be very effective for getting the magnets to snap in properly as well as ensuring that they are flush with the outer edge. Speaking of which, the reason I wanted the magnets to be as close to the outer edge as possible is that I wanted the sliders to be able to stick to each other side to side. This also means that they can stick to any metallic surface on either the flat faces or on either of the edges. Since I've printed a bunch at this point, I've been trying to find all the different ways that you can fidget with them. And one of my favorites is having two side by side and sliding through the steps of the magnets. I am absolutely addicted to this fidget slider. The whole time that I've been editing this video, I've had it on my desk in front of me, fidgeting with it. I'm literally having a hard time right now not playing with it while I'm recording. The locking version is definitely my favorite since it's the easiest to manipulate without accidentally pulling it apart. The configuration that I like the most is with 5 layers, a top slider and a bottom slider, and 3 normal slider layers between them. This gives you 8 total detents along the length of extending or collapsing the slider. The force that it takes to move the slider is definitely less than the metal one, which at first I wasn't really happy with, but the more that I've used it, the more that I actually like it way better. The tension is perfect for me to be able to use it with only one hand and still be able to extend and collapse it. Okay, so the last thing that I want to do now is a side-by-side comparison of the 3D printed fidget slider with the original metal one. Not surprisingly, the 3D printed one is much cheaper, even with having to buy the magnets. I bought the metal one on Amazon for $15 and calculated that the 3D printed one with 3 sections cost me about 85 cents for the filament and magnets. Obviously, you'll have to buy a full spool of filament or use some that you already have, and buy a package of magnets with more than you need for just one slider. But I'm just calculating the cost that went into creating the single slider. The 3D printed slider definitely has some good snap to it, but it's honestly no competition for the click-clackety of the metal slider. It definitely feels nice and snappy, but it's less crisp than the metal one. The 3D printed fidget slider is much more versatile. Its ability to extend in both directions, as well as being able to snap side to side with another slider, just gives you way more possibilities of how to fidget with it. Also, because the magnets are so close to the outer edges, its ability to stick to other metal objects makes it easier to store and gives you even more ways to play with it. Additionally, the ability to arbitrarily decide how many layers you want just makes it that much better. The crispness of the metal slider is definitely satisfying and the weight of it feels premium, but I actually find my hands getting fatigued if I fidget with it for too long. On the other hand, I literally cannot get enough of the 3D printed slider. I've been sitting here fidgeting with it for hours on end as I'm working, and I never get bored of it. I'm kind of surprised to say this, but overall, if I had to choose only one slider to keep, I would choose the 3D printed one in a heartbeat. Every time I sit down at my desk, I subconsciously grab it and ignore the metal one. I hope you'll try printing it out for yourself and let me know what you think about it down in the comments. This episode was a much better representation of my normal workflow and design process. Multiple versions, a bunch of failed prints, and a healthy amount of trial and error to try to figure out the best way to slice the model. If you want to see the full, unedited, real-time process for designing this model, including me being aggressively over-optimistic multiple times, I've uploaded that under design sessions. A link to that video is in the description below. If you liked the video, then like the video. If you didn't like the video, then dislike the video. Either way, tell me what you think down in the comments. If you want to see more videos about random stuff, then subscribe. You know how YouTube works. Stay Moxious.